Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing today. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Without further ado, I'll pass it on to our presenters so that we may begin.
Hello, everyone. Hope everyone had a great last weekend for our Easter break. And so we're back in session for our Friday Happy Math Hour. And so if you need to go to the 1324 room, just click the link. And we will begin with our 1314 session, which we'll be covering basic matrix operations and using matrix operations. So let's continue. So for section 8.1, we're looking at what is a matrix. And so this is what our first thought might be, is thinking about the Matrix, right? The movie. But no, that's not what we're going to be talking about, although I could talk about that for a while. So instead, we're going to talk about a math matrix, which is basically an array of numbers. And as you can see here, you're going to have, we're going to use brackets, and then we have these numbers inside. So these numbers inside are called elements. And so they're made up of rows and columns. So our columns go up and down, and our rows go across. And if you notice here, we have a little a with a subscript 1, 1. The 1, 1 is the location of that number. So here, 1 means first row, first column. So if I looked at this one here, that means that this number is located in the second row, third column. Okay. And so we're going to be using this to help us. So all the matrices are read as m by n, where m is the number of rows and n is the number of columns. And it's also going to help us to find the size of the matrix. Okay, so why are matrices important in our world? So if you are in computer science, you do use matrices quite a bit. And you use them, for example, a lot of us, we used to play video games, or we still play video games. And whenever Mario, in this picture here, for example, whenever he jumps or he runs or he walks backward, all of that in the background is using matrices. And so the computer is using all that mathematical knowledge about matrices to make our characters jump. We also use it to do research, so that we can see how things are connected outside in our web links. We can create paths, which then use matrices to help us learn more about which paths are used more, and so on and so forth. So matrices are a big part of a lot of our careers, but in the background. So we'll go ahead and move on. So the dimension of a matrix, sometimes some assignments might say dimension. If you hear the word dimension, it's just asking for the size. And the size, we're going to be identifying it by the number of rows and the number of columns. And so if you have the first one here, notice it has 2 rows and 2 columns. And so if it has the same number of rows and columns, we call it a square matrix. If it only has 1 row, then we call it a row matrix. And so here we have a 1, and then we have 2 because it has 2 columns. And in this third example, you have 1 column, but it has 2 rows. So the order, or the size, is a 2 by 1. So another word for size besides dimension is going to be order. And then the identity matrix plays an important role when you start doing problems in section 8.3 and 8.4. And the identity matrix, we can identify it by looking at the diagonal here. It's going to only have 1s, and everywhere else you're going to have 0s. Okay. So let's try a couple of examples here. Determine the dimension of each of these matrices. And so if we look at the first one, how many rows does it have? And let me just get my pen out. Okay, so it has one row and it has one column. So this matrix is going to be letter G. Okay, so if we look at letter B, then we can see, or we would ask ourselves, how many rows does it have? So you can see it has one row, and then how many columns? So it has 4 columns, right? So we have 1, 2, 3, 4 columns. So our size of the matrix is going to be a 1 by 4. So that's going to be letter C. And then we have the zero matrix. So if you see a matrix with all zeros, then it's called the zero matrix. And so here, how many rows do we have? And how many columns do we have? So there's 2 rows and 2 columns. So the way we write the size is we write the number of rows, and then we write a multiplication symbol, and then the number of columns. We don't read this as 2 times 2. We read it as it's a 2 by 2 matrix. Okay, so this one's going to be letter B. And then the last one, we have 1, 2, 3 rows, and then we have 2 columns. So this is going to be letter D. Okay. Any questions on identifying the size of a matrix? All right. So one important thing that we want to be able to do is go from a linear system. So these were from section 7, chapter 7. So this was chapter 7. We learned what a linear system was. And we're going to take this system and we're going to be able to convert it to matrices. And the first thing you want to do is get the augmented matrix. And the augmented matrix is made up of coefficients and constants. So the first part in here, this is going to be your coefficients. And then the second part is your constants. Okay, so if you notice here in front of my x, we have a 3. So let me underline that. And so we would put the 3 here. And then we have a 5. And so we would put the 5 in the next one. And then we have a vertical bar that's going to kind of represent like your equal sign. And then your constant is -9, so that will go in here. And we would do the same thing for the x. You have a 1, so we would write the 1. We have a 4, we would write the 4. And then the -10 would be the -10 for the constant. Okay, so it says write the augmented matrix for the system of linear equations. And then what is the dimension of the matrix? And so here we have an x, a y, and a w. And so we want to go ahead and make sure that we include all of those, right? So we have x, y, z, and a w. And so then we have our constants. So in the first row, let me go back. Oh, that's fine. So if you notice here where I have my pointer, I have an x, so the number in front is a 1, so I placed it here. And then we have a 3, so that would go up here. And I don't have a z, so I still need to represent it with the 0. And then I have a -1 for w, a 9 for the constant. And then I have no x in the second equation, so that would put a 0. Then we have a -1, a 4, a 2, and a -2. And then we have a 1, there's no y, so I put a 0. Then I have my -5 and my -6. And then my constant is 0. Then we have the 2, the 4, the -3, and then there's no w, so we include 0. And then we have our constant 4. So here we have 1, 2, 3, 4 rows. So I write down my 4. And then I have 1, 2, 3, 4, 5 number of columns. So that would be my dimension would be a 4 by 5. Any questions on that one? All right, so let's look at another example. It says write the system of linear equations represented by the augmented matrix. So now we want to go from a matrix to an actual system. Okay, so our answer is going to look like something like this. So usually on your WebAssign assignments, they're going to tell you which variables to use. If they don't tell you which variables to use, then you can use X and Y. So here we'll just use X and Y. So I have a 6. So that's going to be the coefficient for X. And so I would have 6X, and then I have a 5. So that would be 5Y. And then it's separated by this dotted line. So that's going to be my constant 2. And then I have a 3X, a -9, and a 0. Any questions on that one? Okay, so let's try this one. So here I have a 1, so that's my X. But then I have a 0, so I have no 0. And then I have my 4. So if it's helpful, you could also write it out as X plus 0Y is equal to 4. However, we know that 0 times Y is just going to be a 0. Okay, so that's why we just have X equals 4 and Y equals 4. So if you notice here, it's really a good thing whenever you have ones in the diagonals, 0 everywhere else, and then you have these two numbers, because from this matrix, we know what X is and we know what Y is. Okay, so in a little bit, that's going to be our goal, is to make sure that our matrix ends up looking like this one here. Okay, so in order to get a matrix that looks like this, in order to write it as something that looks like this matrix, then we use what we call row operations. And so for the row operations, these are the three things that we can do. We can interchange rows. In other words, we can switch them with each other. And these are the symbols that we can use to represent that there was an interchange. We can multiply a row by a non-zero constant. So here we're multiplying by C to every row, every number in that row. And we can add a multiple of a row to another row. So here we're multiplying C to this row, and then we're going to add it to another row. Okay. So here we're going to have our systems of equations. And then our goal is our first step is going to be to write the augmented matrix. And then we're going to use those row operations, which I have listed here as 1, 2, 3. And then hopefully we end up with this matrix where we have ones in the diagonals and zeros everywhere else. We call that a reduced echelon form. And then from here, we can get our solution. Okay. And so notice that's what's happening here. We had our system of equation. We wrote it as a matrix. We did some work by switching and doing all this other stuff. And then we ended up with this. Okay. So we're going to do that right now. But before we do that, let's practice with some of these operations. So here it says interchange the first and the second rows of the original matrix. So this is your original matrix. And all they want us to do is switch the rows. So this row 2 right here is now row 1. Okay. And row 1 is now row 2. And that's all that they wanted us to do. So this is what we mean by interchange rows. If you have to multiply the row by a number, then this is how we would write it. So we're going to multiply a half to row 1. So here I have a 2. If you multiply it times a half, then we get a 1. Okay, so let me use my pen here so we can see it a little bit clearer. Okay, so really what's happening is we're multiplying a half times 2, and then we get the 1. And then a half times -4 gives me the -2. And then a half times 6 gives me a 3. And a half times -2 gives me a -1. So again, what we did is we multiplied 1/2 times the first row, and then the answer we got, we placed it back in row 1. So that is what this means right here. 1/2 times the first row, whatever answer you get, we're putting it back in row 1. Notice that row 2 and 3, nothing changed, so we just wrote them as they are. And then last, add -2 times the first row to the third row. Okay, so here, let me get my pencil out again. So here what we're going to do is we're going to multiply row 2, we're going to multiply -2 times the first row. So we have -2. times the first row. So negative 2 times 1 is negative 2. And then we're going to add it to the third row. So plus 2 gives me a 0. Okay. And then negative 2 times 2 is negative 1. Plus a 1 gives me a, I'm sorry, negative 2 times a 2 gives me a negative 4. Plus a 1 gives me a negative 3. And then negative 2 times negative 4 is positive 8. Plus a 5 gives me a 13. And negative 2 times 3 is a negative 6. Plus a negative 2 gives me a negative 8. And so here we write this negative 2 times the first row plus row 3. And whatever answer you get, we placed it in row 3. Okay, so we're going to do examples here. That way you can see exactly how it works. So here's the system, and it says use the matrices to solve the system. So we know that from chapter 7, you could use substitution, you could use elimination. Now in chapter 8, this is just another way of solving the system. But the first step is to write down our augmented matrix. So we're going to go from this form all the way to something that looks like this. Okay. So the first thing to do is write your augmented matrix. So you have a 2 here. You have a 2, I put my 2 here. You have a 4, I put my 4, 8, 8, and then 1 and negative 1. So 1, negative 1. And then I have a 5. Okay. So notice that in our goal, we want to have a 1 first. Okay. But in our matrix, we have a 2. So if this was a 1, then that would be awesome. There are ways that you can change the 2 to a 1. For example, you can multiply 2 times a half, and that would make it a 1. But if you notice, we already have a 1 down here. So if we switch the rows, then we would have our 1. So we're going to go ahead and switch our rows, and I'm going to represent that by saying row 1, switch it with row 2. And so now I have 1, negative 1, 5, 2, 4, and 8. Okay. So all I did is I switched my rows. And the reason is we want to make sure that we're thinking about our goal, which is for us to have a 1 in this location. Okay. Now that we have a 1 in that location, then you're going to use that 1 to make everything below it a 0. Okay, and the way we're going to make that a 0 is using row operations. Okay, so we're going to take, so here I have my 1. Right here's my 1. And then I have a 2. Well, in order to make this 2 become a 0, it would be nice if the 1 was a negative 2. Because if this was a negative 2 and I added to a positive 2, then negative 2 plus 2 is going to be 0. Okay, so what we're going to do is we're going to multiply negative 2 times row 1. We're going to add it to row 2. And whatever answer we get, we're going to place it back in row 2. Okay, so I'm going to demonstrate that with my writing here. So we're going to multiply negative 2 times row 1. So negative 2 times 1 is negative 2. And then we're going to add row 2, which is a positive 2 here. And so negative 2 plus 2 is 0. Your answer, we're going to write it in row 2. Notice that my row 1 doesn't change, so I just wrote everything there because we're not changing that. Now, you also need to multiply negative 2 to every single number in that row. So our next one is going to be negative 2 times negative 1. And then we're going to add it to the 4. So we end up with 6. So then we place the 6 in the next column. And then the last one is negative 2 times 5 is negative 10 plus an 8 would give me a negative 2. So I write down my negative 2. Okay, so far in our goal, we have our first column complete. So we already have our 1, we have a 0. But now we need to have the next column, we need to have a 1 here. So let me just, so So we want to have a 1 here. So always work with the diagonals first, because if you change the 0 first, if I try to make this a 0, then it's going to change these numbers over here. So always work with the diagonals first before making anything else zeros. So now we're going to check. So we have a 6. So in order to make this 6 a 1, I can multiply the 6 times 1 6, because 6 times 1 6 is going to be a 1. Okay, so I'm going to represent that with 1 6 times row 2, and then my answer, I'm going to place it in row 2. So I have 1 6 times 0, 1 6 times 6, and 1 6 times negative 2. And so that's 1 6 times 0 is 0, 1 6 times 6 is 1, and 1 6 times negative 2 is negative 2 6, and then negative 2 6 can be reduced to negative 1/3. Okay. And notice my first row did not change. So now we have our 1 here, so that's great. But now we need to make this negative 1 a 0. So notice that they're already opposites of each other, 1 and negative 1. If we add them, we get a 0. So all we have to do here is add row 2 plus row 1. And what we're trying to change is this negative 1. So we're going to put our result back in the row 1. Okay. So let me see. So we would have 0 plus 1 is 1. 1 plus negative 1 is 0. And negative 1/3 plus 5 is going to be 14/3. Okay. So our answers, we can now get our system. So here, this represents x. So we would have x is equal to 14/3. And y is equal to negative 1/3. Okay, so this process here is using the method of Gaussian elimination. Okay. Now the good thing is you have other ways to solve the systems. You can use all the Chapter 7 methods, or in Section 8.3 and 8.4, you'll learn a new method as well. Okay, so you have options. Okay, so in a little bit, if we have time, I'll show you how to use the calculator as well to check your work. Okay, so here we have this system, and we want to solve it. Okay, so remember our goal is 1 0 0 1. Here I have a negative 3 and a 6. If I switch the rows, it doesn't help me. So I'm going to make this negative 3 a 1. And in order to make it a 1, I'm going to multiply by negative 1/3. Okay, so we're going to have negative 1/3 times negative 3 gives me a 1. Negative 1/3 times 4 gives me a negative 4/3. And negative 1/3 times 22 gives me negative 22/3. So I find out my 1 here. Now my next goal is to have a 0. Okay. In order to have a 0, I need to make sure that this 1 becomes a negative 6, so that when I add it to 6, it's going to be 0. So what we can do is multiply row 1 by negative 6, add it to row 2, and then our answer we're going to put in row 2. Okay, so let's see that. So let me go ahead. We're not going to change row 1, so I'm just going to write it down. So I wrote it here. And then row 2, we can do the work now. So we have negative 6 times 1 is negative 6 plus 6 is 0. And then go to the next one. Negative 6 times negative 4/3. And then plus a negative 4 is going to give us 4. So negative 6 times negative 4/3 is going to be a positive 8. And then minus a 4 gives me a 4. And then negative 6 times negative 22/3 is going to give me a positive 44. Plus a negative 28 gives me 16. So now I have 1 0. My next step is to make this 4 a 1. So I can make this 4 a 1 by multiplying by 1/4. So I'm going to have 1/4 times row 2. And my answer I'm going to put in row 2. The first row, we're not going to change it, so I just write it as it is. And then the second row, I'm going to have 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times 16 is 4. So we have our 1, so that's great. So now I need to make this a 0 up here. So if 1 is 4/3, then I can just add them. So I'm going to multiply my second row by 4/3. And then I'm going to add it to row 1. And then my answer I'm going to put in row 1. So I'm not going to change row 2. So I'm just going to write down my row 2. And then now I'm going to do the work. So I have 4/3 times 0 is 0. Plus 1 is going to be 1. And then 4/3 times 1 is 4/3 minus 4/3 will give me 0. And 4/3 times 4 will give me 16/3 minus a 22/3 gives me a -6/3, which is the same as -2. So now you can see that our matrix is reduced. This is in reduced echelon form. So I can say that x is equal to -2 and y is equal to 4. So this would be my solution. Okay. So let me go to the next slide, section 8.2. Section 8.2 is, in my opinion, actually a lot easier than 8.1. So you're going to see this is a little bit easier. So matrix operations. And actually, before we move on, let me show you how to check your work before we leave this topic. Okay. So let me go to, I guess we can leave it here. I'm going to share my screen. So just remember these numbers here, and actually let me put them in the chat. That way I don't forget. So we have -3, 4, 22, and 6, -4, and -28. Give me a second. And then our answer was x is -2 and y is equal to 4. Okay, so I'm going to stop sharing this right now, and then I'm going to share my screen so that you can see where you can check your work. So if you go to decimals.com, that's one place where you can check your work. And just click on graphing calculator. Let me get my charger really quick. Hold on. Before my computer dies. All right. So if you go to decimals, at the top, you have this key here that says Math Tools. So if you click on it, there's a matrix calculator. So if you click on matrix calculator, and you want to click on new matrix. So our matrix that we were working with was, it had, let me go to the chat really quick. It had 1, 2 rows and 3 columns, okay? So you want to make sure here we have 2 rows and 3 columns. And then our numbers, -3, 4, 22. So I will put that here, -3, 4, 22. And then the other number is 6, -4, 6, -4, and -28. Let me double check. Yes. Okay, and then you just press enter. And so it's going to be here for you already. So to solve the system or put it in reduced row echelon form, you click on this RREF, that just stands for reduced row echelon form. And then your matrix that you put in here is A, so you just press A. And then it just does the work. So if you notice on the right side here, it has 1, 0, 0, 1, -2, and 4, and that's it. And so this is something you can use to check your work if you like. And then there's also in your TI 84s and 83s, I'll put a link in the chat. I have a YouTube channel that shows you how to use the calculator to solve these matrices. And then it also shows you how to do the decimals. That way, in case I went too fast, you can look at that video and it'll show you how to do it. Okay. And then, of course, you'll also be able to add and multiply and do some other stuff with the matrices. Okay, so let me put the file back up. And let me go to the section that we're in. All right, so in 8.2, we want to talk about when are two matrices equal to each other, when can we add them, when can we multiply them, and when can we subtract them, and so on. Okay, so two matrices are equal if they have the same dimension, in other words, they're the same size, and their corresponding entries are the same. Okay. Entries are just the numbers that are inside of the matrix. You can add two matrices if they have the same dimension, if they have the same size. And then if they do, we just add the entries, corresponding entries. And I'll go over that in a little bit. Scalar multiplication is just when you multiply some number to the matrix. And that number C is what we call the scalar. And basically you multiply C into every single number inside the matrix. And then subtraction of the matrices, if we have A minus B, we can write it as an addition problem with a scalar of -1, which we'll talk about here in a second. Okay, so for example, if I have A and then I have the matrix B, and for letter A, we want to do 3 times A. Okay, so let's do 3 times A. So 3 is what we call a scalar. So notice I wrote 3 and then I wrote our matrix. And so what we're going to do is we're going to multiply each number by 3. So 3 times 2, 3 times 2, 3 times 4, 3 times -3, and so on. And so if we simplify, then we end up with 6, 6, 12, -9, 0, -3, 6, 3, and 6. So my answer would be this matrix here. And then we have -b. So -b is just the same as -1 times the matrix. So we're going to multiply -1 to everything inside of the matrix. So -1 times 2 is -2. -1 times 0 is 0. And then we have 0. -1 times 1 is -1. -1 times -4 is 4, and so on. So this is our answer. Now in the letter C, they want us to subtract 3a minus b. Okay, so we have 3a minus b, and so I like to write it. So 3a was what we found down here. So I'm going to write it here. And then b, -b is this right here, so I just wrote it here. So if we wanted to add these or subtract them, you have to make sure that the order or the size is the same. So this is a 3 by 3, and this is a 3 by 3, so we're good. So to add, we're going to add corresponding entries, and that just means 6 plus a -2, and then 6 plus a 0, 12 plus a 0, -9 plus -1, and so on. So if we do that, then we get 6 plus -2 is 4, 6 plus 0 is 6, 12 plus 0 is 12, -9 plus -1 is -10, and so on. Okay, so that's how we would add two matrices together. If possible, find a plus b, a minus b, 3 times a, and 3a minus 2b. So one of the common questions I get asked a lot in chapter 8 is if people multiply matrices, they don't have enough spaces here. So these green arrows will control how many rows and how many columns will appear for you here. So if you feel like you need more rows, then you would click the green arrows here. So you would click the bottom arrow. If you need less, then you would click the top one. Or if you need more columns, you would click the the first arrow. If you need less, you would click the second arrow. So if you need to change the size of your matrix, you use the arrows here. Okay, so let's do the first one, A plus B. So A, the order is 2 by 3, and the order for B is 2 by 2. So this size is not the same, right? And so if they're not the same, then it's impossible to add them. So you would type in the word impossible. Okay. So let's solve for X and Y. This is a different problem. So here, if we have this matrix is equal to this matrix. So all we know is that they're equal to each other. And in order to be equal, they have the same size, which they do, 2 by 2 and 2 by 2. But the numbers inside have to be the same. So for example, I have a -4, I have a -4. I have a 6, I have a 6. So this X, if I know that they're equal, then that means that this X has to be a -3. And this Y has to be a 21. Okay, so your answer here is going to be X equals -3, Y equals 21. So if we look at the second one, we have an 18 and an 18, a 5 and a 5. Then we have X is equal to 2X plus 5, and 16 is equal to 5Y minus 4. So we can set up two equations. X is equal to 2X plus 5, and 16 is equal to 5Y minus 4. So we can solve for X, subtract the 2X on both sides. So we end up with negative X equals 5, and then X is equal to -5. And then 16 equals 5Y minus 4, add the 4 on both sides. So we end up with 20 equals 5Y, divide by 5, Y is equal to 4. Okay, so that is how we would solve for the X and the Y. So for the next one says solve for X in the equation where A is equal to this and B is equal to this. So X is equal to 2A plus 2B. So here, X is equal to 2 times A, so this is my A, and then plus 2 times my B. So I'm going to multiply the 2 inside first. 2 times -3 is -6, 2 times 2 is 4, 2 times 3 is 6, -4, 0, and 8, and then we get 6. 2 times 2 is 4, 2 times -5 is -10, 2 times 5 is 10, 0, and 6. The orders are the same. This is 2 by 3, this is 2 by 3, so I can add them. -6 plus 6 is 0, and 4 plus 4 is 8, +6 plus -10, -4, -4 plus 10 is 6, 0 plus 0 is 0, and 8 plus 6, 14. So this would be my answer. Okay, so here's another one. It says solve for X. So it looks all crazy here, but what we could do first is actually just take the equation and solve for X. So we have, I'm going to add 2A on, I'm going to add the -2X to the left side, so that becomes 2X equals -2A, and I brought my 4B to the right side, so I have minus 4B. And then we have divide by 2 here, so we're going to have -A minus 2B. So now I can just substitute the matrices. So here I have a -1, I have my A, and then I have my -2 and my B. The order is the same, 2 by 3, 2 by 3. So let's multiply the -1 into the parentheses, or not parentheses, but to the matrix. So we end up with 2, -1, -1, 1, 0, -4. And if we multiply -2 in here, we get 0, -4, +4, -6, 0, and -6. So we can add them. 2 plus 0 is 2, -1 plus -4 is -5, and -1 plus 4 is 3, -6 plus 1 is -5, 0 plus 0 is 0, and -4 and -6 is -10. Okay, so now when it comes to multiplication. So multiplication is a little bit different than the addition and subtraction. So for addition and subtraction, the order had to be the same. But for multiplication, if you have two matrices, here's matrix A, and the order is m by n. And then matrix B, the order is n by p. In order for us to be able to multiply, the number of columns of the first matrix has to be the same as the number of rows of the second matrix. In other words, these inside numbers here have to be the same. If they are the same, then we would be able to multiply. The outside numbers, the m and the p, that tells you the size of the actual product. So when you multiply your answer, the size will be an m by p matrix. Okay. So I'll give you an example here. So here is this matrix times this matrix. First thing, identify the order. So this has one row and two columns. So this is a 1 by 2, and this has two rows and one column. So I'm going to check the inside numbers, or the number of columns of the first rows of the second matrix, and notice that they're the same. So what that means is that you can multiply, and after you multiply, your result is going to be a 1 by 1 size matrix. Okay, so my result is going to be a 1 by 1. So how are we going to multiply? We're going to take the first row and multiply it to the first column. In this example, it's obvious, or it's what's another word? Straightforward, because you only have one row and one column. Okay, but you always take the row and then you take the column. And then you're going to take the first number times the first number, the second number times the second number, and add them together. Okay, so for example, it's going to be 4 times 1, 4 times 1. And then we're going to have 1 times 2, 1 times 2. The result, add them together. So 4 plus 2 is going to be 6. So this would be your answer. Okay. So now let's look at B. So this is a 2 by 1 and a 1 by 2. The inside numbers are the same. So yes, you can multiply. And your result is going to be a 2 by 2. Okay. So again, remember, you want to take the first row, which is this one, by the first column. And then you're going to take the second row by the second column. So let's go ahead and do that. So we have our first row times the first column is 4. And then the first row times the second column is 1. And there's no more columns, right? You don't see no more columns. So we're ready to go to the next row. So the next row is 2 times the first column. So 2 times 4. And then we're going to have 2 times the second column, 2 times 1. So if we multiply these out, then we get 1 times 4 is 4, 1 times 1 is 1, 2 times 4 is 8, and 2 times 1 is 2. So with these, it's a little bit, when you see a bigger matrix, they'll make a little bit more sense. Okay, so let's try this one here. So it says find a squared where a is 3, 1, negative 1, 2. Well, a squared is just a times a. So I have my a and my a. Let's check the size. This is a 2 by 2, 2 by 2. So notice that the inside numbers, the ones in red here, are the same. So that means that yes, you can multiply. And the green numbers are going to be the size of your result. Okay, so we're going to take the first row, which I have here. I underlined the first row. And I'm going to multiply 3 times 3, this right here, and 1 times negative 1. So that's going to be your first number for the first column. So notice that my arrow here is now going to move to my second column. You still use the same row. So 3 times 1 is right here, and then 1 times 2, which would be here. We don't have no more columns, so now we're going to go to the second row. So I'm going to underline it for you. So now we're going to have negative 1 times 3 will be down here, 2 times negative 1, and then I go to the next column. So negative 1 times 1 and 2 times 2. So now we're going to simplify this stuff. 3 times 3 is 9. 1 times -1 is -1. 9 plus -1 gives me an 8. Okay. And then 3 times 1 is 3. 1 times 2 is 2. 3 plus 2 is 5. -1 times 3 is -3. 2 times -1 is -2. Plus -3 is -5. And a -1 and 2 times 2 is 4. If we add 4 and -1, we get a 3. Okay, so for multiplication, it does take a little bit more practice, okay? But it's okay. With practice, you'll be able to get it. And then again, you can check your work using the computer, and I'll show you in a little bit how to do that as well. So it says solve the following given the matrix below. So B times A. So let's see if we can multiply this. So B is 2 by 2, and A is 3 by 2. So notice the inside numbers are 2 and 3. So they're not the same, so we cannot multiply. So this is going to be impossible. So we would just write impossible. Okay. Any questions on that one? Okay, let me share my screen so I can show you the calculator, the TI-84. Let me just open it up first before I share my screen, because I need to find it on my desktop. Hold on, give me a second. Oh, and then I was gonna put the link to the calculator. Okay. All right, so let me share my screen. Okay, so let me see if you can see my calculator. Can you guys see my calculator or no? Yes, okay, cool. Okay, so if you have an 83 or an 84, you can just ignore my desktop. It looks it has a lot of stuff there. But if you're using a graphing calculator, then the way you would work with the matrix is you would put second matrix, and then you have to put the stuff in there. So you would go to edit and then pick a matrix, so A, and I'm gonna do a 2 by 3 matrix. And I'm just gonna make up numbers right now because I don't remember what the other numbers were, so I'll just put a 4, a 5, and 12. Hopefully it has a solution. And then a 1, and an 8. Okay, so you enter your stuff in there, and then you just second quit. And then we go to second matrix again, and now you want to do some math with it. So if you go up, it's easier than going down. So if I click the up arrow, and then I go to this one here, RREF. So I press enter, and then you're gonna do second matrix again, and then you have to remember which matrix you're using. I'm using A, so I just press enter, and then I press enter. And if you notice here, I have my 1, 0, 0, 1. So I can say that X is equal to 28 and Y is equal to -20. And then that's my answer. Okay. Now, if you're gonna multiply or add or something, let me just add something in here for B. 2 by 3. So let's make this a 3 by 1 is fine. So 8, 6, and 4. Second quit. So if I wanted to multiply these, I would go second matrix, and then I'm going to call A, and I just press multiplication, and then I call B, and then I press enter, and that would be your answer. But notice if I put them backwards, B, it's a 3 by 1, so this number is not the same as the 2. It's gonna not work, right? So B times A, and then it gives you that, tells you it doesn't work. Okay, so that's how you would use it here. In section 8.3, you would be using, in the 8.4, you're gonna use this DET, that's determinant. And then in section 8.3, we're gonna look at inverses. So you would use this key right here. Okay, so I just wanted to share that with you in case you have a graphing calculator. If you don't have a graphing calculator, then you can use the decimals to check your work. And there's another one, so let me just give you the link to the video. That way I don't forget it. So, and if you're not in my class, you can always go to this website or to my YouTube channel, and I have videos for each section of the course. Okay, so let me just find the calculator one. Actually, I have it in the 13-14 class. Hold on. So if you notice here, I have all the sections recorded. I don't see it. I guess it must be in the other folder. Let me check one more folder. And let me go slower because it should be in here. Graphing, no, not the graphing. Here it is. So let me get this link for you, and it shows you how to use the calculator. Okay, here it is. So that is all I had for today. Next week we'll look at examples from 8.3 and 8.4, and then I believe we have 2 more sessions left. The last session is just a review for the final, I believe. Okay, so if you have any questions, feel free to hang around and ask us any questions you might have. And I'll pass it over.
Thank you, Ms. Chuka, for your presentation. We do want to remind you all about our previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take that survey and take a few minutes to fill out the other short survey to receive credit for attending. Before you all leave, I want to share the TVE sessions that we will have next Friday. So at 1 p.m., we will have an EPCC culinary arts tour. And at 3 p.m., we will be back with Happy Math Hour with 1314 reviewing inverses and determinants of matrices, and Math 1324 reviewing basic concepts of probability, permutations, and combinations. Thank you all for coming in today. We hope you all have a lovely weekend. Please remember to sign in to receive credit for attending. We hope to see you all again next week, and thank you so much for coming in today.